In this video, we're going to look at finding the nth term of quadratic sequences. I'll start off by finding missing terms using the quadratic nth term, and then for people on the higher paper, I'm also going to do finding the nth term of a quadratic sequence. As usual, make sure you have a pen and paper nearby to note down the things you must remember, particularly the finding the nth term. There's a lot to remember, so it is worth writing down. Listen again, rewind and pause as you need to so that you make sure that you understand it fully. When there is a pause symbol in the top left, I am going to ask you to do something. Make sure you do that so you can constantly be checking your understanding of this process. And finally, try not to have any distractions around you, no music or TV, be focused on this work. Okay, so here's a quadratic sequence. Now, a question will often tell you it's a quadratic sequence, but you can easily tell it's not linear simply by trying to find the common difference. So here, the difference between 5 and 11 is a plus 6. From 11 to 19, we've got a plus 8. 19 to 29, we have a plus 10. Now, in a linear sequence, those numbers would have all been the same. Here, they're not. They're increasing. If I ask you to find the next term, all I'd do is say, well, the next one is going to be a plus 12, and 29 plus 12 is 41. The next one after that, we're going to do plus 14 because my little plus is going up by 2 each time. 41 plus 14 is 55. So this is a GCSE question. Write down the next two terms in the following quadratic sequence, and all you have to do is what we exactly what we just did there. So from 9 to 13 is a plus 4. 13 to 19 is a plus 6. 19 to 27 is a plus 8. The next one, plus 10. 37. And the next one, plus 12, is 49. So 37 and 49 are your next two terms. And that's all there is to do to that. You just need to find the pattern that will help you find the next term. You may also be asked to find a later term. So in this case, it's asked for the 10th term in the sequence. Now, you could sit there and work out what the first one is, the second one is. That'll take a long time though. Instead, if it's the 10th term, we know n equals 10, because that's what the 10th term is. That's why we use the n in there. So substitute 10 into the expression, and you'll get the 10th term. I'll say this now, be really careful to remember your rules of BIDMAS. You need to do the powers, the index, before you do the multiplication. You will get the wrong answer. So it is 2 times 10 squared plus 4 times 10 minus 1. 10 squared is 100 times 2 is 200 plus 4 times 10, which is 40. Take 1, 239. Substitute the term in and make sure you remember BIDMAS, particularly if there is a number in front of the n squared just there. Okay, here are 4 questions. The red and yellow want you to find the next two terms. Simply continue those quadratic sequences to find those two. The green wants the first 4 terms, so you are going to have to substitute in what n is 1 is, n is 2, n is 3, and n is 4 to get 4 different answers. And the purple question wants to only know the third term, so just substitute n is 3 into that expression. Pause it now, and when you unpause it, the answers will appear. Okay, here you go. The answers are up now. For the red one, if you have a look, you should have had a plus 3, plus 7, plus 11. You'll notice that 3, 7, 11, it's going up by 4 each time. So the next one would have been plus 15, which gives us 40, and then plus 19 to get 59. The yellow one, we went up by 8, then we went up by 12, and then 16. So the next one is a plus 20 and a plus 24 to get 82. For these, you need to substitute in each time. So if I do n is 1, 1 squared is 1 plus 2n, which is 2, gives us 3. N is 2, 2 squared is 4, 2 times 2 is also 4, 8. N is 3, 3 squared is 9, 2 times 3 is 6, you get 15, and n is 4, 4 squared is 16, plus 2 times 4, which is 8, gets you 24. For the purple one, you need to substitute n is 3 into the expression, so you have 2 times 3 squared plus 4 times 3 minus 14. 3 squared is 9, times 2 is 18, 4 times 3 is 12, and then you have minus 14. 18 plus 12 is 30, 30 take 14 is 16. Okay, on the higher paper, you're also expected to find the quadratic nth term as well. So here is a sequence, and we're going to find the nth term of it. Step 1, just like a linear, we're going to try and find a common difference. Now, when we first do it, just like a minute ago, you can see that what we call the first difference, they're not the same. So we're going to do it again. 7 to 11 is plus 4, 11 to 15 is also plus 4, and 15 to 19 is also plus 4. So the second difference is consistently a 4. If it is not consistent on the second difference on a quadratic, something has gone wrong. So double check your numbers because you may have miscounted somewhere. Once you know what that common difference is, because we are now using n squared rather than n, we are going to halve the 4. And so we're going to get 2n squared. So the 4 is halved and it gives me a 2n squared. If I'd had a common difference of, say, 10, then that coefficient there would have been a 5, so it'd be 5n squared. If it had been 20 for the common difference, I'd have 10n squared. Whatever the number is, half it and put it in front of n squared. The next bit I like to lay out on a table just to make it a little easier to follow, because if you're a bit untidy here, it can get confusing. I have n, which is just my term numbers, and then I have my original sequence as I started with to begin with. What I'm going to do is I'm going to work out what 2n squared is, and I'm then going to subtract it. So 2n squared, and please don't forget your BIDMAS here, is 2. 2 squared is 4 times 2 is 8. 3 squared is 9 times 2 is 18. 4 squared is 16 times 2 is 32. And 5 squared times 2 is 50. The next step now is to subtract one from the other. 6 take 2 is 4. 13 take 8 is 5. 24 take 18 is 6. 39 take 32 is 7. And 58 take 50 is 8. So I now have this new sequence. I'm going to write down here 4, 5, 6, 7, 8. Not a very imaginative sequence, but there it is. And we're going to use this as a linear sequence, and we're going to solve and to work out what the nth term of my linear sequence is. Well, plus 1, plus 1, plus 1, plus 1, so it's going to be 1n. You can just write n. My 0th term, if that's the way you've been doing it, would have been a 3, so it is plus 3. From this point, you now know then that this bottom row here is n plus 3. We also got from this bit a 2n squared. So we add those two together now to give us our nth term of 2n squared plus the n plus 3. What you can do at that point, and I do recommend this, is substitute a number back into one of those. If I just clear a space here, I'm going to use n is 5. N squared is 25 plus 2 is 50, plus 5, plus 3 is 58. There's a good chance then, because that's what I wanted, that that's right. Okay, here we have another sequence. What I'd like you to do here is pause it, have a go as far as you can work out yourself, unpause it, check your work, and then pause it again if you need to, and repeat until you get to the end. Okay, so the first step will be to find the common difference. Make sure you've got it paused. Give you a chance now. Okay. Find the common difference. We're going to find the first difference first, and then we're going to find a second difference. Plus 2, plus 2, plus 2. That's nice and consistent. I'm going to halve the 2, which gives me 1n squared. You can also write here n squared. Both are fine. I'm going to throw in a little table. I'm going to work out what my square numbers are, which is 1, 4, 9, 16, and 25. I'm now going to subtract those one from the other to give me 5, 6, 7, 8, and 9. 5, 6, 7, 8, 9 is a linear sequence, which is n plus 4. All I do now is take my two parts, add them together, 1n squared plus n plus 4. Okay, here are two more to have a go at. I will warn you, these are both a little trickier. There are negatives later on, so take it step by step. Refer back to previous models if you need to try and get it done. The method does not change just because there's a negative or a decimal or anything like that. So pause it now, have a go, and then I'll pop the answers up. Okay, the answers for these, here we go. If we look at the red one first of all, you should have managed to get your second difference of 4, and 4 divided by 2 is 2, so it's 2n squared. You should then have substituted 1, 2, 3, 4, and 5 into your 2n squared. That will give you this little sequence here. Subtract the 2n squared from your original sequence, which will give you this remainder line. And if you work out the nth term of this linear sequence, it is minus 3n plus 5. Combine them both for 2n squared minus 3n plus 5. The green one is more or less the same. The first difference here is a decimal each time. It's not a problem. Still do a second difference. You get 1. Half of 1 is a half. So you should have done a quadratic of 0.5 n squared. Subtract that from your original to get a new linear sequence of 3, 5, 7, 9, 11, which the nth term for that is 2n plus 1, and then just add them both together. And remember, you can, once you've got your nth term, substitute a number back into it to double check that you're right. Okay, from here, you need to either go back if you're still unsure and give it another go, make sure your notes are crystal clear, and then have a go at the worksheet.